All right, welcome. Today we are jumping right into something super fundamental, something that's at the very heart of how computers make decisions. We're talking about logical operators. So let's break down what these things actually are.
So have you ever really thought about this? I mean, how does a computer actually decide yes or no? Every time you log into an app or a character in a video game makes a move, there's a decision happening. It feels really complex, right? But somehow, the machine boils it all down to a simple yes or no. How does it do that?
Well, the secret is, it's not magic. Not at all. At the end of the day, computers are just following a set of really simple, really clear rules. And what's kind of cool is that these rules are actually a lot like the ones we use every single day. And those rules, those are what we call logical operators. I love this analogy. Think of them as a computer's street sense. They're the tools a program uses to figure out if something is true or if it's false. And that simple answer, that true or false, is what tells the computer what to do next.
Okay, so let's start with the first one, which is kind of the strictest of the bunch. It's the AND rule. And the key thing to remember here, the only thing, is that for the final answer to be true, absolutely everything has to be true. No exceptions.
And this is the perfect example, right? The club bouncer. Think about it. You could be 25, but if you forgot your ID, sorry, you're not getting in. Or you could have a perfectly valid ID, but if you're only 17, again, not getting in. Both things have to be true. You have to be over 18, and you have to have your ID.
Okay, now this is how we map it out formally. It's called a truth table, and it's super useful. Just look at it. The only, and I mean only, time you see a T for true in that final A and B column is on that very first line. Why? Because that's the only line where both A and B are true. If even one of them is false, boom, the whole thing is false.
And here's how we write that in code. This is a little snippet of JavaScript. See that and, that double ampersand? That's the symbol for and. So the computer is asking the exact same question as the bouncer. Is the age greater than or equal to 18, and does this person have an ID?
All right, so that was and. Now let's look at its much more laid-back cousin, the or rule. This one is way more flexible. All you need is for at least one thing to be true to get a yes.
Oh yeah, we've all heard this one before, haven't we? It's the classic parent rule. You can watch TV if you finish your homework, or you clean your room. You don't have to do both. Finish your homework? Cool, go watch TV. Clean your room? Awesome, TV time. And hey, if you do both, even better. The only way you're not watching TV is if you do neither of them.
And check out the truth table for or. It just perfectly shows that flexibility. Look how different this is from the and table we just saw. The only time you get a false result is on that very last line, where both A and B are false. As long as you've got just one T on the left side, the result on the right is true.
And in code, especially in a language like Python, it almost looks like plain English. The code is just checking, is homework underscore done true, or is room underscore clean true? If the answer to either of those is yes, then the whole condition is met. Simple as that.
Okay, our third and final operator is honestly the easiest one to grasp. It's the not operator. Its entire job, its only job, is to just flip whatever value it's given, to just invert it.
And this is just so intuitive. You can go out only if you are not sick. So the condition for going out is that being sick has to be false. If the variable is sick is true, then not is sick becomes false, and you gotta stay home. It's just the exact opposite of the current state.
And look at this truth table. It's about as simple as it gets, right? If A is true, not A is false. If A is false, not A is true. That's it. It's a perfect flip every time.
In a lot of programming languages, you'll see this as an exclamation point. So when you see @is sick, that's just a programmer's shorthand for saying if the condition is sick is not true.
Okay, so here's where it gets really powerful. The whole point is that these simple operators, and, or, and not, they don't usually work all by themselves. Their real magic, their real power, happens when you start chaining them together to build much more complex and, nuanced decisions.
So let's put it all together with a real-world scenario. Imagine you're trying to get into a tech event. Okay, rule number 1, you must be registered. That's an and. Rule 2, you have to come early or know someone on the inside. That's an or. And finally, rule 3, you must not be on the ban list. See that? We've got all three operators, and, or, and not, all working together to make one single complex decision. And what's so cool is that all of that logic, all of those rules, can be translated into this one clean line of code. The computer checks, is registered true? And is the condition early or know someone true? And is not banned true? All three of those chunks have to come back as true for you to get in.
So why does any of this matter? Why have we gone through all this? Because these simple rules are, and I am not exaggerating here, running the entire digital world that we live in, every single day.
I mean, think about it. Every single time you log into an app, it's checking if your username and your password are correct. When you go on Amazon and filter for products, you're using and or. The choices a character makes in a video game, the stuff that pops up in your social media feed, it's all being controlled by these exact same fundamental rules.
And that's really the key takeaway here. Logical operators, they're basically the language of how computers think. And once you understand that language, you're not just a passive user of technology anymore, you become someone who actually understands how to give it instructions. You can start to control what it does.
So that leaves us with just one final question. You now get the basic street sense that powers pretty much all software. You know the rules for how machines think. So, what are you going to build with it?